RTDs, they are one of the most common resistive sensors that we have. The abbreviation is resistive temperature detectors. So, well, obviously it's a converter from temperature to resistance. They are made of a metal, and very often, if not always, the metal is platinum. We'll come back to later why platinum is very popular. And they have a rather large range from typically -200 to +800 degrees Celsius. Rather expensive. Well, it's not impossible to buy, but I guess you know that platinum is as expensive as gold actually, and you have a small amount of platinum inside, thus driving the cost of the sensor. And they are based on the predictable relation between metal resistivity and temperature. Well, metal resistivity. So, if I go back to the equation again, that R equals rho times L over A. This is the resistivity, the rho. And for platinum, that is a given number. However, the rho is a function of temperature. So the resistivity will change as the temperature changes. So here we have in this example how the resistivity changes as a function of temperature. And you see, for example, for nickel, it has a non-linear, this one is curved, and it even changes abruptly at one point. So, but it's much more sensitive than platinum, as it changes faster, steeper curve than platinum has. And you have, for example, copper, more sensitive, but then again, more non-linear at the end. Platinum is quite linear, even though if you look closely, it looks like it dips a bit downwards like that, and it sure does, but not very much. It's really quite linear. Also, the thing about platinum is that it's a material that does not oxidize very easily. Like if you've seen copper, which becomes green, for example, when it's in contact with air, platinum tends to keep its shininess. Therefore, it does not react with oxygen very much. So the resistivity is not very time dependent. It will keep its resistivity over a long time. The most common platinum-based RTD is PT100, which has more or less become the synonym of RTDs. PT100. PT is the chemical symbol for platinum. Large P, minor T, but never mind. So in our engineering world, we use capital letters all over. 100 is the resistance at 0 degrees Celsius. So PT100 will have 100 ohms at 0 degrees Celsius. There are also some other PT RTDs available, like PT1000, PT5000, and guess what? The resistance at 0 degrees is 1000 ohms and 5000 ohms. And you also have others, but definitely the most used one in the industry is the PT100. Also, it has a rather linear response. So you can say that the resistance RT is R0 multiplied by 1 plus 3.85 times 10 to the minus 3 times temperature. And this is basically the format. This is the format that we had for the equation that output equals K times input plus bias. That is also a straight line, and so is this. This is a straight line, and this is a straight line. So that describes a really straight line. However, in real life, there is a small non-linearity connected to it, and therefore this is the accurate equation for the PT100, where this is the bias, this is the straight line sensitivity. These two terms represent the non-linearity. And if you see here, the B term has a factor 10 to the minus 7, while the A term 10 to the minus 3. So the B term is really small compared to the A term. But however, the higher the temperature, you square it, so it becomes more and more valid or significant as the temperature goes up. And the C element is actually only used for negative temperatures, and it's really small. In most cases, we actually use some kind of computer. So we have our sensor, and then we put this into some kind of, for example, microcontroller, like an Arduino or something. And if you have a computer, why should you bother to use the simplified version? Why not use this version? If you have a computer, you have a calculator, why shouldn't you use the more accurate equation? So therefore, because of the properties of PT100s, that they are quite linear, they are really accurate, they have a very good range, and also they don't drift much with time. They keep their properties over time. Those are the three main reasons why the PT100s are so popular in the industry. The price, however, is a bit more expensive, so for non-critical purposes we tend to use others, like the one I will present in the next film, the thermistor.